first meeting of the year. Obviously, it's been an interesting year since we've gone virtual, but I think things are going reasonably well for us so far. In fact, we're really starting out with a bang this year. So this is this session actually has a record number of RSVPs. We've never had this many RSVPs. This is over 320 RSVPs. Very happy about that, and in fact, also very happy to have a very, very good topic. We've been waiting for this topic for a little while, and really we were looking for the right presenter for this topic, and I do believe we really have the right presenter. So I'm very, very happy to actually introduce Heba. Heba is my coworker at Microsoft. She'll introduce herself, obviously, in a moment here, but really happy to have her. Do take advantage of her time today. She's very, very knowledgeable with Kubernetes. In fact, I'll tell you, when I run across issues with Kubernetes at work, I ask Heba for help. So she's very, very good about that, and she's also very, very helpful, and why she's presenting with us today. So without further ado, I'm gonna just get started here. I'm gonna put the focus screen on Heba in just a moment. I did want to thank Jakarta EE for continuing to sponsor us for these virtual sessions. Without them, we wouldn't have the Quarkus sponsorship and really wouldn't be able to do that. All right, so I think that's that for me. I'm going to put the focus on Heba, and I'm actually going to turn off my video for the rest of the presentation. I will be around to help do Q&A and moderation, though. So Heba, it's all yours.
Right. Let me start with sharing my screen and making sure everyone can see. All right. So Reza, can you see my screen?
I can see your screen. You sound good. You can see your screen. Everything is beautiful. I think you can go ahead. No problem at all.
So thank you so much, Reza, for inviting me today. I'm so happy to be here, and I'm so happy to have the chance to share what I've learned so far during my Kubernetes journey with you all. Well, a short intro about myself. I'm Heba Layouti, a software engineer at Microsoft, working with Azure engineers team and customers help for helping them to use Azure services and the cloud native technologies. Before that, I am a long-term Java developer, more than 10 years plus. When I joined Microsoft, I didn't expect I would write Java anymore. But guess what? I'm writing Java every day. So I'm writing Java more than any other language within Microsoft. I'm also a cloud native fan, contributed to a few open source projects in Kubernetes segs, and I was a part of Kubernetes release team for 1.18. Today's journey, it's a little bit long, but hopefully it will be a good one. We will start with discussing why we need to use containers and what containers runtime, and then we will learn how to Dockerize our Java application and run it using Docker. Then we will move over to discover Kubernetes world together and know about the basic concept to be able to deploy our application into Kubernetes locally and in the cloud. We will talk about best practices to run your Java application on Kubernetes, and finally, we will try to touch base with Quarkus and how it works, and having a small comparison between Quarkus and Spring Boot. So, why do we need containers? For many years now, enterprise software has typically been deployed on a physical servers, or as we say it, bare metal. I expect most of us agree that installing on bare metal made the software painfully difficult to move around and difficult to update, and for sure the resources boundary problem, which is, it was normal to find out in case you run multiple applications that one of them would take most of resources, leaving other application almost without anything left. The only solution while using the bare metal is to install each application on a separate server, which is very expensive. And as well as it's hard to manage or scale resources. And most of the time it will be underutilized because this is this is the fact. This is the real world. Not every time the whole server will be utilized. So after a few years, after lots of years, they came with the virtualization platforms. And we called it's known as hypervisors. The virtualization allowed multiple virtual machines to share a single physical system. Each virtual machine emulates the behavior of the entire system. It has its own operating system and storage and I/O and everything isolated. So in this isolation way, provide a level of security for the application to be run and without affecting any other application. That was great. That was great improvement. So the VM could be cloned, could be copies, could be migrated. Virtualization allows better utilization for resources in a physical server and allow better scalability for sure. So the cost is better now, the hardware we utilize better now, but on the other side, virtual machine most of the time are very large, gigabytes, each one containing a full operating system. So many virtualized apps need them to consolidate to run. So it's not portable. It's not the booming thing that the business demanding. So we need something more with more speed, more agile, saving cost, and can help us growing fast. So here is the containers. Containers work a little bit like VM, but they have more relaxed isolation properties. So by having this isolation properties, they can share the operating system among multiple applications. They are also lightweight, and similar to VM, a container has its own file system, share of CPUs, memory, process space, and more. And guess what? It's just megabytes, and you will have you will have your container running very fast, and for sure cost-wise more preferred than anything else. But it's so important to know that the container technology is not new. It has been built into Linux in form of Linux container over 10 years. And similar operating system level virtualization has also been offered by other companies like Solar's containers. So what happened is they introduced a lot of companies introduced open container initiative. So Open Container Initiative is an open source project under Linux Foundation. The purpose of it is to develop industry standards for container format and container runtime software for all platforms. The starting point for the OCI standard was Docker for sure. And this is why always, Docker name a company with the container. But container concept has been already, founded long time before Docker introduced. So again, the idea of OCI or Open Container Initiative is to ensure that the fundamental building blocks of container technology are standard, so that everyone can take advantage of them. For sure, Docker is by far the best known and most widely used container platform. But there are other technologies on the container landscape, each with their own individual approaches and use cases. For example, the Linux container, LLX, or Hyper-V containers, or RKT or Rocket as per se. So other tools, actually, it's just a part of Docker, not end-to-end platform like Docker. For example, the Podon, it's a container engine. The containerd, it's only the daemon, or RC, it's only the container runtime. For sure, Docker is a big system, and if you wanted to know more about container, there's many resources in the internet, and actually, I've added some of them by the end of this presentation. Now, let's talk about the workflow, the Docker workflow. We need to understand how can we, run containers by the end of this. What's the relation between Dockers and containers? Are they the same thing? Are they, is it only the tool? What is that? So let's say that we have the three main components here: client, server, registry. The client is a tool or the CLI that you're installing in your machine or on your pipeline to communicate with Docker. The server is the backend for Docker. Let's say it's the backend for Docker, which has a Docker engine. So if you wanted to talk to Docker, use your client to talk to server that has the Docker engine. The registry here is the images artifact, like Docker Hub or Azure Container Registry or SER in Amazon. We use it to push the images after we build it, and we can pull it anytime. Once you push this image to the registry, you can share it with other teams, other people, or make it public to use. So let's see how this works. So first thing, okay, I wanted to call Docker with a command. Let's say, for example, it's Docker build. Hey, let's build the Docker image. So once we build the Docker image, the Docker engine and the server start to build your image. Okay, once you have your image, it's not a container yet. It's just a definition about how the container will run. Now you need to have another CLI that say to the Docker engine, hey, run this image. So now the Docker engine will pick the image and run it to be a container now. Sometimes, as we mentioned before, we need to push this image to the registry. Sometimes we can build everything local if you wanted to test it. But if you wanted to share it with someone else, if you wanted to run it in another place, it's best practice for sure to push it to a Docker a Docker registry. And for sure, you can pull it anytime, here or any other place. So basically, this is the Docker workflow so far. Any question before moving to a demo how to Dockerize a Java application?
No questions so far, Hiba. You can keep going. If there's any questions, I'll let you know.
Okay, so I will start to to build a very small Docker image for my application. First of all, this is a very small application. It's a mini node. It's to upload an image, write a description, or write your note, and just upload it to your database. So very simple. We don't have anything in particular. It's a Spring Boot application, and it calls MongoDB actually. So we will run MongoDB locally first and see how can we build our first Docker file. So first of all, let's create a Docker file. We have to call it this name, and we have it to have it, like in, like outside the source folder. It's like that. Okay. So what else? Let's try the first thing. We need this container to run a Java. Okay, to run a Java program. So this is the first thing. We will define the base layer that container will run
Hiba,
from.
if I can interrupt you for a second, the font is very, very small, Hiba. So yeah, if you
Okay.
can increase the font a little bit, and then I can tell you when it looks good. Maybe a little bit more, Hiba.
Okay.
Just a little bit more.
That's
Yeah, that's perfect. Right there. That's perfect right there.
all right. Perfect. So this is the first step. We wanted our container to run a Java application. To be able to do that, we need to something like install Java in this container, or make this container know that we need Java in somehow. So here, anything we need to add to this Docker file, we use from. Okay, so okay, this is the first step. The second step uh, is to build a folder that will contain our jars. So here's the thing. I will say, hey, this is my work directory, or the image work directory, or specifically the container work directory. Anything, I will add it here. So after that, by default, Docker image will have a root access, and this is a security issue. You don't want anyone to, if for somehow has an accessibility to your image or your container, to run whatever he wants. So we are creating just a group, sorry, a user for this image. Okay. Now we need to pass some environment variables, like for example, the port we wanted to run. So here is the port. Okay. Now, okay, I didn't do anything yet. I'm still, like preparing for my work. So here is the jar file. So I'm saying here, after you run the Maven build install, or Maven build package, you will have a jar file. So I'm telling Docker, please copy this jar file from the target folder to my working directory. So I have this jar file, or my application, as a jar file inside my container now. And finally, I need to run this jar file, right? So here's the thing. So I'm saying here, hey, execute the Java, okay, and I can pass any Java variables I wanted, and please execute this jar file. And voila, this is the Docker file. This is all what we need to run a Docker file. So let's try to run this now. As you can see, as I mentioned before, my application is a Spring Boot application. And let me try to, okay. So inside the resources here, I am just, have just one environment variable, which is the Mongo URL, okay? And I'm running it locally, and nothing else. It's all about, I'm using FreeMarker, Spring Boot FreeMarker for the interface, for front end. So I'm just setting the template, and that's it. So what we need now, we need to come here. I will try to maximize this. Just 1 second. I'm trying to make it a little bit. It's so. Let's try to see if you can see or not. Otherwise, I will
Not yet,
try.
Hiba. So you need to
Yeah.
increase the font size. So if are you on a Mac?
Yes, Mike.
Okay, so try Control plus, or rather Command plus, and it should hopefully increase the font size of the window a little bit.
Yeah. I think it is. Thank you.
Yeah, and need to do
Okay.
it a little bit more. Still very small.
Yeah, sure. I will. Okay.
A
So now,
little more, Heba. Just a
okay,
little. Yeah, that's perfect right there.
okay. So now, as you can see, I am in my project now. It has the source, the POM, and here is the Docker file. Let us now just build our application. Just clean install. Okay, and we have this error here because we need the database to be started. Let me start it here. Now, what should I do now? I should install Docker for sure. So you have to install Docker for Mac or for Windows. It's available and it's really easy to install. So now I will say a build Docker build, and I will use this name. It's mini notes Java application. That's it. Okay, let's see what's happening now. Okay, so as you can see, all these steps is the steps I am creating. So let's try to count them. It's 1, 2, 3, 4, 5, 6, 7. Okay, so these are the 7 steps I'm creating. I added. So here is like getting the GRE, creating a directory, and then creating a user, setting the environment variables, and copy the jar file from the target, and finally execute the Java. Okay, so now I just built my image, but do we have a container yet? No. According to the workflow we've done, it's only an image. We need to run this image. So how can we run this image? Let's first try to make sure that the image is already there. So if we say Docker images, we will have all images we have right now. So you can see, yeah, it's already there, just create it, okay? So as you can see, the tag here is latest, which is okay, but how about just add a version for this image, just in case? So Docker tag my image name, it's Java, and I will name it. It's also main node Java, but I will give it 1.0.0. Okay, so this is the first version, and that's it. If we go here again, you will find another image, but with different tag. Okay, it's the same image, but the tag is different. All right, so now we are using MongoDB, right? But because our application now is running inside a container, okay, it will not be able to see the local running DB. We will need to run MongoDB as a container as well. So how can we do that? MongoDB has an image. It's available in Docker Hub. You can just pull this image and you can use it. But now we have 2 different containers. And the benefit from having containers that they are isolated. We cannot let them talk to each other unless we create something called network in Docker. So it's very easy. I already created one. It's Docker network. If we list them here, you will find one of them. It's just a bridge. Okay, so the network here is just a bridge between these 2 containers. Okay, so okay, this is great. I will start first by making clear here. I will start by running the Mongo. So now it's Docker run, right? The Mongo image. The name of this image is Mongo, and I will make sure if it exists already, like delete it and add it again with RM. And I will pass the network, okay? Because this is the only way that I can tell my application to talk to another container, okay? And I will name it Mongo as well. So the container now, I'm creating a container by running Docker run. I'm creating a container called Mongo as well. Let's try. Okay. So as you can see here, I have the Docker. I have the Docker running here. Okay. So now we need to run our image. So the same as we've done before, we will do it again. Let's say we are running Docker run to create our container. I will give it a name. I will give it a name to this container, which is mini node Java. We can name it anything else. I wanted this container to run on port 8080. And if this container exists, please remove it first. I will pass the network, the same name, which is mini node. Okay. And we need only one environment variable, which is the Mongo URL. Okay. Let me paste it. Yeah. Okay. So I'm having only one environment variable, and to pass an environment variable to this Docker container, just -e before. Okay. And as you can see here, why like instead of localhost, I'm having now the container name, the MongoDB container name, which is Mongo. Okay. And finally, sorry for that. Finally, I need to add my image name, which is this. So again, I'm using Docker
But
to
did you
run my
notice the
container.
typo? You missed a K in network.
Okay, thank you. So again, just to make sure that we understand what's happening here, we have a Docker to run our container. We will name this container mini node Java. It will run inside the Docker container on port 8080. If it exists, please remove it and use this network to communicate with any other container within this network. The environment variable we need is the Mongo URL, the MongoDB, and the container name for Mongo with the port. Okay, and here is the image name. Let's see what's happening here. And as you can see here, it started. All right, so our application started. Let's try it. Okay, so localhost. Oh, yeah, we have a mini node here. So we can go here. I have some images. Let's demo and let's upload this, publish. Oh, yeah, I have one here. And as you can see in the background, it's like running inside a Docker container. So our application is ready is running inside Docker container. Okay. Okay, so this is how we can run a Docker container. This is how can we build it, how we can build it, and how we can run our application, our entire application as containers. So two containers talking to each other Yes, they are isolated. We can make them talking to each other by creating a bridge or network inside Docker. And yeah, that's it. So before moving to another topic, do you have any questions? Anyone have any question so far?
So Heba, it's up to you. I think one person wanted to understand the Docker run command a little bit more. If you have time, you can explain it. So we do have
Mhm.
another question. How the environment variable used in inside of, okay. So inside of a Java application, how do you reference an environment variable? If you can explain that.
Okay, so
And
we have
also another person asked, are you using Docker desktop? I assume the answer is yes.
yes. So as you can see here, this is the Docker desktop. It's really cool, but I wanted to show you everything, like as a command in CLI, because this is like the fact, or this is the real life. But here is the Docker desktop. You can see your images here. As you can see, I've just created the image and the new image with the tag 1.0.0. And here is the containers running. So here is the mini node Java container and the Mongo container as well. You can delete this container, stop this container, and as well you can delete the image. So this is the first question. The second question regards the Docker run. If you have a specific thing to ask here about, let me try to to say it again. So Docker run here is my CLI will talk to the Docker engine and the server side, okay, which is here is like the Docker here, okay. So I'm talking to the server side, telling them I need to create a container, okay. The container name will call mini node, will have a name, it's a mini node. I wanted this container to run on 8080. If there's any other container, please remove it first and create it from scratch. It's an optional. You can remove this if you want. But make sure if you have this container before while you're testing your application, just delete your container first. Now, sorry. Now I wanted to run this container within a network inside Docker runtime, container runtime. Why? To be able to have a mutual place for all other containers to see each other. Okay. One way. Sorry, because I'm making it very big. So my screen is not down. Okay, so because okay, let me stop this first. It's easy. Here and here again. So because I have a MongoDB as an environment variable, so I passed it here for the container. This is one way to pass an environment variable. So I pass this Mongo URL environment variable, and the value is MongoDB with the appropriate port. Okay. And finally, this is the image I wanted to run inside this container I'm creating. This is the second question. Please, if you have any question, let me know. The last question is, how can we pass environment variable to our Docker container? We have two ways. Either like that, it's an environment variable called port, and the port value is 8080. We can do the same here. So we can have our MongoDB environment variable like URL, and this is the value. Okay. This is another way. So we have two ways to pass our environment variables.
Okay, so Hiba, another question is a couple of questions actually. So one question is about when you are running a Docker container, how do you access that whatever is running in that Docker container from outside of it? So let's say you want to run your web application, in your IDE, and you're running Mongo as a Docker image. How would you do that? And the next question is, what happens to the MongoDB data when you shut down the container?
It will go away. Okay, so we don't have any persistent storage for now. So once this container closed, every data will just disappear. It will be deleted because the container already deleted.
Unless you can mount a volume, right? You could mount a volume.
Yes, we can mount a volume. We will do this, and like when like later in this presentation. But for now, if you kill this this container, you will lose everything. Okay. About how can we see this outside? So here in Docker, there is something called service. Okay. Yes. Oh, sorry, service list. Just 1 second. Yeah, okay. So actually we can have like Docker service and Java. Okay, so if you wanted to see anything related to the Docker outside the Docker container, you can create a service. You can create a new service, and this service will have a URL. You can use this URL to like to talk to these container outside. We will have this once we like we reach to the Kubernetes side, but let's wait for this for a while.
So Hiba, I think you can just explain the -p parameter to explain how do you access something running in a Docker container from your local machine. I think that's that may be worth explaining.
Maybe this part, like the P, this is the exposed. Yeah, this is the yeah, for sure. But if you have like, yeah, this is the only way. Yeah, this is actually the right way for now. It's we have this port. We can talk to any container inside Docker using this port. Yes, this is for now. Yeah. Okay. More questions?
No more questions right now, Hiba. I think we can move along.
Okay. So as we can see now, it was a little bit easy. It's not that hard to create a container, to create a Docker image and run a container in something like Docker container runtime. It's easy. It's not that hard. But imagine that you have a real project with many containers to run, and you wanted to be able to scale them up and down according to the load. You wanted to keep an eye on all of them in case any failure happened. So you will start to panic. Sure, it's like, how can I do that? I need something like a container orchestrator to do that for me. And here Kubernetes come to rescue. So basically, the name Kubernetes is originated from Greek, meaning helmsman or pilot. Google open sourced the Kubernetes project in 2014. It was the result for more than 15 years of work inside Google. Kubernetes is a portable and extensible open source platform that manage the containers workload for you, manage the containers and all services you wanted, and facilitate both declarative configuration and automation as well. And it's largely and rapidly growing ecosystem. They have at least two new release every year, 3 to 2 release every year, with tons of enhancement and new capabilities and issues for sure to be solved. So Kubernetes provide you with a framework to run distributed systems in a resilient way. It takes care of scaling and failover for your application, and provides a deployment pattern you can follow with any different application, whatever like if you have a Java application and a Python application, you can use the same deployment pattern to deploy this to Kubernetes. And actually, Kubernetes can easily manage a canary deployment, for example, for your system. So why do we need Kubernetes? I think, as we mentioned before, keeping containerized application up and running can be really complex because they often involve many containers deployed across different machines. Kubernetes provides a way to schedule and deploy those containers, plus scale them up and down. Kubernetes also have a service discovery and load balancing built-in functionalities. Kubernetes has storage orchestration, and it has secret and configuration management. It has self-healing built-in service as well. So, yeah, it will be a little bit hard for you in the beginning to understand this ecosystem, but once you understand it, you will find it's like a magic. Just deploy your container and it will take care of that. So a high-level overview about the Kubernetes architecture. As you can see here, the user can talk to the Kubernetes cluster using CLI or dashboard or API or anything else like that. Once you have a command here, this command will go to a master machine, or we called it control plane all the time. And this master machine has actually four main components. We will talk about them in a minute: controller, API server, and scheduler. The API server is responsible to talk to nodes or VMs. We call the VMs inside Kubernetes cluster node. So the API server will talk to each node according to lots of configuration, which is available or not, which application we are trying to call, is it in node number 1 or node number 2, and each node has multiple pods, and we will know what does it mean in a second. So control plane has, as we mentioned, four components. The first one is the controller. The Kubernetes documentation uses a very good example to describe what is the controller. It is like you have a heat thermostat in your house. The position of dial, its desired state, and the current temperature is its actual state. And the thermostat constantly applies or removes heat in effort to keep the two in sync. This is exactly the controller. This is how the Kubernetes controller works. It is a loop that watches the states for you inside your cluster, and they make changes as needed, always working to maintain your desired state. Controller can track many objects. Controller can track what workload you are running right now and where, the resources available to these workloads, and many other functionalities for sure. So the second component is the API server, which is basically expose the Kubernetes API to other component to talk to. So it is the front end for the Kubernetes control plane. The third one is the scheduler, which is, like watches if there is any pod or any container. Let's say for now, any container has been created. Okay, which VM is available to run this pod or this container, and it's like it keeps running all the time to discover which is the best place to run your container. The last thing is a key value store. most by default it's SD, but you can use any other key value store if you want it. And it's a consistent and a highly available key value store used by Kubernetes to back all data we are talking about right now. It's like all nodes information, all like what we wanted to schedule, which APIs is running right now, what's the controller operations has been done. So all this information will be stored in the key value store. So now I have a container. Where is this container in the last architecture? I couldn't see it. I need to run my container. This is all what I need. So consider that we have multiple containers. Kubernetes has a resource called pod, which is the smallest unit in Kubernetes cluster that you can create and manage. A pod is a group of one or more containers with shared storage and network resources. Okay, so this is the smallest thing we can talk about in Kubernetes, not a container, but it's a pod. So a pod is list of containers. Okay, so now what else? I need to deploy this pod, right? So there is a virtual concept here called deployment, which is very important. The deployment is a resource object in container that provide declarative updates to applications. It also allows you to describe an application lifecycle, such as which image to use for the application, the number of pods you want it to run, and in like the way in which they should be updated. How can we update them? And more very useful information. So now the container inside the pod, or many containers inside the pod, and the deployment is just a decoration about this pod that describe how can we deploy this pod. And finally, it's the node or the VM. So I wanted to deploy this pod to this node. So the node is the VM. These are the main concepts we need to understand, so we can understand how how things works in Kubernetes, and how can we deploy our application to Kubernetes. Any questions so far?
So a more high-level question, Hiba. Basically, somebody is wondering, when would you consider Kubernetes versus Docker Swarm, and does the size of your cluster and number of pods or nodes, does that have any bearing on whether you should use Docker Swarm versus Kubernetes?
Actually, let's say that there are actually like the same tool or the same concept. They're the same tool for the same concept, but Kubernetes has more growing community that take care of this and make it easier and stuff like that. But Swarm is totally fine. I don't have right now like a comparison how Swarm is doing compared to Kubernetes, but from what I saw in the past couple of years, Kubernetes has become like a default if you wanted to orchestrate your containers or distributed system.
So let me provide my opinion, if you don't mind, Hiba. Is that
Sure,
okay?
sure,
Okay.
sure.
So I think 2 or 3 years ago, people asked this question more frequently. They don't ask it anymore. The reason is, if you go look at Google Trends, Docker Swarm is basically either declining or flatlining, versus Kubernetes is having exponential growth. So, all the major cloud vendors, Microsoft, Google, Amazon, they're all behind Kubernetes, and really nobody has picked up Docker Swarm.
Yep.
Docker Swarm is a lot more feature poor. It has some orchestration mechanism in a very basic sense. So it basically allows you dynamic scalability and self-healing. But other than that, Kubernetes has many, many more services: stateful sets, replicas, ingress control. There's a number of services, some of which that Hiba will we'll touch upon. So honestly, there's not much reason to be considering Docker Swarm at this point.
Yeah, thank you so much for that. It's a very useful answer, actually. Any other question?
One more question, Heba. So somebody didn't. It seems like you should explain Node a bit more. So they're not. I think the question is the node the same thing as a virtual machine? In other
Yes.
words, yeah.
Yeah. It can be a virtual machine. It can be a physical machine. According to how you're using Kubernetes, either on-prem or on cloud. But yes, it's the same concept. It's a virtual machine. By the end of everything, it's a virtual machine.
Okay, that's all the questions for now.
Okay. So now let's go to the part 2 of the demo. And create a deployment file. And while we creating a deployment file, we will talk more about what each YAML file means and how can we do that. Let's for just organizing thoughts to create a directory called cube or whatever, and create our file, our first file, which is the mini note.yaml. Okay, this will be our deployment file. And let me make it bigger now. So we need a way to deploy our container that we created, okay, which is the mini Java node, the mini node dash Java to run inside inside the Kubernetes. So we have two scenarios actually before starting writing the YAML file. We have two scenarios. The first one is running running a local Kubernetes, a small version of Kubernetes, let's say that, and making sure that everything is working fine. And then we will go and deploy this application on AKS. So let's go back to our terminal and do something really cool, which is, okay, so we have our Docker image now tagged as we mentioned, okay? It's tagged by 100. Okay, I need now to create another tag, and I would say why now? I create another tag from this Docker image. It is mini node Java, okay? And I will add my Docker Hub username and a name of the Docker image I wanted to push, okay? But for now, I wanted to just create this, okay? So I created another tag, another tag here, but with my Docker Hub username. So why we need to do this? If we go here and just go to the Docker, for example, I would use Docker Hub here to push my image. I will sign in. You can see here that I already have all my repositories from previous work. Let's say that. I didn't have anything to be a private, so all of them are public, but you can for sure have your Docker Hub in a private repo instead of public, and you can publish your image to the Docker Hub, okay? So now anyone wanted to use this image, you will just, run Docker push and this name and the tag, which is 11 here, 1001, and you will have my image, okay, remotely in your machine. So this is what we will do now. We will do Docker, and actually one thing, to be able to push to Docker Hub, you have to create a Docker image with your username as as a start point here. So my username was HIPAA, IoT here. So I use this. So now I will try to push my image. So Docker push HUI note Java, and the tag is 1.0.0. Okay. Okay. Now it's pushing. Actually, it's uploading my image to the Docker Hub. Okay. Now my image is, like applicable for anyone. Anyone can use it. One thing I wanted to mention that you need to log into Docker. So it's Docker login to be able to make your bash or your shell see your account. Okay. But I already did that. Sorry for doing that. Okay, so now one part is we have our image already in the Docker Hub, ready to use from anyone else. The second thing is to create the deployment file. Let's go and try to deploy it, to create it very step by step. So the first thing, as we mentioned, we need to create a deployment file because this is the deployment object we need to deploy to Kubernetes. So we will say here API version, which is which API machinery, or this kind I will use. It was introduced in which version. So basically, most of them will be in apps v1, but it's different, and you can get this very easily from Kubernetes documentation. The second thing is to specify the kind, and now the kind for this YAML file is a deployment. Now I will add a metadata, which is just to specify the name for this deployment. I will call it mini node. Okay, it's just a name for my deployment, nothing else. And now the new section called spec, and inside the spec is the specification for my deployment, like how many replica I need. For that case, I need just one. So I need to create how many pods. Okay, how many pods? So I have my container inside the pod, but the pod is the smallest thing in Kubernetes. So if I wanted to create multiple containers from the same application to scale up, I need to do this now. So for now, we don't have any need for more than one. But we can upgrade this for sure in the future. And I will add this here. For now, it's a selector and it's a label. So there is another concept in Kubernetes called label, and you have to mention this with anything related to this service. We will see this in a bit. Now, this is the specification for my pod or for my deployment. I need to start creating my pod. I'm still, where is the container? How can I, define the container to run? So I will create the template. Okay, I will give them another label here, and another this template. There is a spec. Okay, another spec, and inside the spec, I will list all my containers I wanted to run. Okay, and I will specify a name for this container, which is, for example, mini node Java. Okay, and I will specify where to get the image, and here to come the need for pushing this image that we have just created. So Kubernetes will try to pull this from Docker Hub. okay, or from the ACR in case you are in Azure, or ECR in Amazon. But by default, they will try to get this from Docker. Okay, I will specify the port for this container. Which is 8080. I will also specify the environment variable I need, which is the MongoDB URL. So now inside the spec, I have list of containers. You can have one container or many containers, but it's recommended to have just one container, so you can scale up and down easily. So my container called mini node Java, and this is the image, this is the port, this is the environment variable, okay? And I can specify another thing like, hey, I need my image. Let's put it here. I need my image policy to pull it all the time, every time. So if this is always, so every time you are deploying this YAML file to Kubernetes, they will go and pull the newer version from your image. There is another, you can specify it's like no, just once, or maybe never. It's like, hey, get it once and that's it. So there's another values for this, but let's keep it like always, because if we have any changes, we needed to like connect to this images directly, get this images directly. And actually, this is the deployment. This is all what we need to let Kubernetes deploy our application. So the YAML file from kind deployment.
Hey, a quick note. You have a typo in containers. You're going to wind up getting an error.
Thank you. So I have a name for this deployment. I specified how many pods I wanted to run, and inside this template, it's all about my pod, okay, or my containers. Okay, so this is the container, the name, and everything I need. So this is good, but let's say that Kubernetes wanted everyone to have a service. It's like an interface. From our Java perspective, it's exactly the interface. So Kubernetes say, I cannot handle a deployment by, like it's like by default. You have to create an interface and let me, like handle this deployment either inside the cluster or outside the cluster. So let's say I wanted this to be exposed outside my cluster. I need a service or an interface to say that. For example, I wanted to run another container that I don't want anyone to see it outside my cluster. I wanted this interface to explain this. So there is another kind here. So let's say API version v1, and the kind here is service. Okay. So service, it's exactly the interface for your deployment or for your pod, okay? And as we mentioned, it's anything, you will find it's very convenient because it's almost the same. So you'll have a metadata and you'll name it whatever you want. I will name it here, it's mini node service, okay? And I will start to write the specs for the service, okay? So it's only three important things. Okay, the first one is the selector for the service. The selector is which deployment do you want me to handle? So the service, the first question will ask which deployment. So the selector here should match the match label here, okay? So, and this is why this is very important. So you need to add to your deployment a selector and add a label and go here to the service and use the same label. And this is how Kubernetes will hook to the deployment and the service together. Okay. The second important thing is the ports, because this will be your interface. So you are saying here, hey, you can interact with this service using the 8080 port. Okay. And the last thing and the most important thing is the type. So Kubernetes service has 3 types: cluster IP, node port, and load balancer. Cluster IP1 is like, hey, this is private. This is private deployment. I don't want anyone outside Kubernetes to know anything about this. So the service will handle this, will handle that no one can reach this deployment. The node port is, hey, my application is running in many VMs or many nodes. Okay, so I need only other nodes to access it, but nothing else. And the third and last one is the load balancer. The load balancer is, okay, I want everyone to see my deployment, so make it public. So this service will create an external IP that you can see this application. So we will stick with the load balancer for now. And this is all what we need to deploy our application. Okay. But again, Mongo, we need Mongo here. So let's create another YAML file for Mongo to deploy it inside our Kubernetes cluster. So let's call it Mongo. Okay. And let's make it bigger. Okay, so I will try to make it very quick this time. So it's the same thing, but we are deploying a database, not an application. It doesn't matter. For Kubernetes, it doesn't matter. This is a deployment unit he expects, or Kubernetes expects. So deploy whatever you want. I don't care. Just give me the image and I will deploy it. Okay. And this is a little bit, like was a magic for me. It was really amazing. So again, the deployment here for Mongo, I named it Mongo this time. I gave it a selector as well, a label name Mongo as well. And this is my pod. My pod called, my pod will run just one container called Mongo. And this is a public image called Mongo, whatever, okay? And this is just a version for this image. And I will run it to this port. So as you can see, this is the same port here, okay? Right, so also fast forward, I will create the service. As we mentioned, every deployment needs a service, right? Okay. So here's the service. So, hey, you didn't specify a type, right? So it will be by default cluster IP, which is private, okay? So if you didn't specify any type, Kubernetes will make it private for you, or cluster IP type, okay? So this is great. But do you remember the question that one of you asked, a while ago, that if my Mongo container crashed or, something happened, I will lose my data, right? I don't want this. So I need to create a storage inside my Kubernetes cluster in case this container fails. I don't want to use my data, right? So here is another kind. Okay, here's another kind called what? Called persistent volume. Okay, so here I'm about to create a persistent volume inside my Kubernetes cluster. I will make it fast forward for the timestamp. So as you can see here, hey, I created a persistent volume claim. I give it a name, and specification for this persistent volume is that the access mode is read-write. Okay, And the storage, I will just, like give it something very, very small because I don't want it something big. It's just a demo application, but you can for sure change this whatever you want. Okay, so this is cool, yeah, but my deployment doesn't know anything about this. So I just create a persistence volume, but deployment doesn't know anything about that. So I need to go back here and define this persistent volume inside my pod. Okay, so I'm saying here, hi, this is a volume. Take care that I need this volume to be to this pod to see this volume actually, and I will call it storage. Okay, and the claim name should be the same name for this persistent volume. Okay, so now I hooked the volume with my deployment. And I wanted my pod, because it's isolated, remember, I need this pod to know this volume and mount it inside my pod. So I need this volume to be mounted inside my container, inside my container. So I will add another property called volume mount, the same name as the name I defined here for the volume for the pod. And this is a path, just a path. And we are ready. Do we have any question before going to the next part?
Let's go over to Minikube, Mininote YAML a second, Hiba, please.
Sure. Mm-hmm.
I think in the container port, you'll need, I don't know if this is going to cause an issue or not, but I think it's better to put a space in there.
Yeah. Yes.
Yeah.
Sure.
Okay. So a couple of
Thank
questions,
you.
Hiba.
Mm-hmm.
You can ask them, or you can answer them or not. I'll let you sort of determine that. I think people are a little bit confused about the syntax if they haven't seen the syntax before. So if you want to explain in the spec, in the deployment spec, the selector and the template elements look very similar typically. If you can explain what the difference between those two things are, number one, and also what is API version. It's a little bit of a confusing name for some people, I think.
Yeah.
API version is apps v1 for deployment, and for something for service, it's simply v1.
Mm-hmm.
So if you can explain those things a little bit, I think. But also, these are basic syntax questions. If you want to skip them, that's also okay with me.
So the second one is easy to answer right away, to not take time. But the second one, it's like we need to open the like the specs and see what's the difference and like what's the hierarchy. But let me try to explain it very quickly. The API version is the syntax that Kubernetes decided to have with each YAML file that tell you which version from Kubernetes has this kind. So, for example, the service kind or the service type was one of the earliest components that has been established in Kubernetes. So you will find it in V1. Okay. So by time they started to add more syntax and started to add more components. Okay. They don't want to break your service that you have been created long time ago. So you will find that it's another name, like apps v1. And actually apps means that this kind related to the application specific, which is, hey, I'm deploying an application. I'm deploying something related to the application. So the API version is when this kind has been introduced to Kubernetes users. Okay, you don't have to know all of them. Let me go here. You will find many samples. Just run like Kubernetes.io, which is the main documentation for Kubernetes. try to search for anything like deployment. Okay, you will find the API version is the first thing. So replica set, for example, we will not discuss this for sure. But like anything is written here. You don't have to know which kind introduced in which version. This is not important at all. Okay, just like search. It's just one Google search away, and you will find anything you want. Is that okay?
Yeah. So, Hiba, I'll briefly give my interpretation. Basically, each of these things you can think of it as an XML element, right? So there's a specific definition and a type that you are saying. If you want a service, well, each of those services have different definitions in Kubernetes, right? So V1 is a certain type of comes with certain features. If Kubernetes enhances a version of those and it's a backward incompatible change, that'll be service of type of V2, and that'll have different metadata and different features. So it's really, API version is really nothing much more than saying, hey, I want this particular Kubernetes service or Kubernetes element, and this is the version I want. That's all.
Yeah, exactly. Thank you, Reza. All right. So now we need to.
So Eva, there's a couple of questions. So if you can explain the differences between selector and template. I think that was another syntax. But if you want to ignore it, I'm also completely okay with that.
Okay. Yeah, no problem. So the selector here is it's like you're labeling your application, so they can be defined or it can be found in different places. This is typically the selector. So you're saying, hey, anything with the many nodes label, okay, inside the selector. You can use it like here. So the selector here should be equal to the selector there. So Kubernetes can understand to like hook them together. But the template here it's basically the description for my pod. Okay, so the description doesn't do anything related to the label. Okay, so the label has a lot of privileges. We can talk about the label privileges, like for a long time. But for now, all what you need to know is to add label, so you can hook any other type or any other kind to each other, like here. The template is the description for your pod, is the detailed description for your pod. Okay.
Right. Last question here, Eva, and again, feel free to ignore this. So, is there a way to reference because there is a dependency, right? Depends on dependency chain. The MongoDB YAML file is ultimately a dependency for the Minikube. So the question is there any way to express that dependency?
There's many ways. For sure, if you didn't implement any of them, and I did that because it's very simple for now. I want it to be very simple to be able to understand. So you have to, deploy MongoDB first, and then the mini node. But we have an option that the containers has a special type called the init container, and the init container is it's like, hey, run this container first and then run any other container inside the deployment. I didn't want to do that with the database because it's like best practice to separate anything with different functionality in a separate deployment. Okay, so now you have a deployment, you have separate deployment. How can I meet this dependency? You can introduce the liveness and readiness, for example, liveness and readiness prop. So this container will keep failing without you noticing anything until it will retry for a couple of times until the MongoDB is ready. After many, if you specify like 5 times or 6 times and still failing, it will try to delete the pod and like create it from scratch because something is not right. This is the only way, not the only way. This is one way to link or to make these dependencies. But again, the deployment is something called, like a dependent, an independent component. You cannot make anything dependent on, like another deployment. You have to make it in a like a decent way, like a props, liveness props, readiness props, or maybe it's if it's like a log tool you wanted to use for your pod, you can run it as init container. It's like initialized container inside your pod.
Okay, I just want to briefly say something to folks out there. So, folks, it's already close to an hour and a half. This is a long presentation for us, right? So I think I'll let Hiba decide when is a good point for people to leave if they have other obligations or it's bedtime for the kids or what have you. You don't have to keep staying on, but at the same token, probably what we're going to do is let Hiba finish her session. My guess is that's going to take about, let's say, 2.5 hours, and you're obviously welcome to stay on. I'll stay on and we'll keep the session going. But at the same token, I'll let Hiba decide when is a good point, because it's already an hour and a half. It's beyond our normal session for sure. So I'll let her decide to let you know, hey, when you can, when you're when is a good break point, when is a time you could you could go away. And also keep in mind that we are recording this session. So if you come back to this Quarkus link that you used when you did registration, you can always watch the recording. So even if you left now, you could watch the recording later. So that's also a choice. Yeah, that's it. Oh, one more question, Hiba, that come up. Just to clarify the hierarchy, the Mongo and Mininode are in their respective deployments, but run on the same node. I'll let you explain this. I'll let you explain this, Hiba. It's not necessarily on the same node, but it might be.
Yeah. So here, because we only have one node, for example, they will run on the same node, but it doesn't matter. Okay, it doesn't matter at all. They can run in different nodes. This is if you don't have like a specific requirement for this application to run on the same node, which you shouldn't. If you have like a real microservices, you shouldn't. So let's Kubernetes handle this for you. Okay. So you shouldn't like aware which deployment will run on each node. It doesn't matter for you. But for sure, there's lots of way to determine in your deployment file to deploy this deployment or this pod in a specific node. Okay. But here now there is no obligation for running in the same node. All right, so I will try to move forward to the next part. Now we have our deployment file. I hope it's ready. It's ready to use. Now we need to have a place to run this. So we will use a Minikube. Minikube is a tool to let you run a single node Kubernetes cluster in your machine locally. There's similar tools like Kind or anything like that, but Minikube is more familiar for anyone. You will hear anyone in Kubernetes community, using the Minikube. So how can we use Minikube? Oh, it's very simple. If you remember, if we go here in Docker images, you will find in Docker containers. I already have a container. Let me first say Minikube start. Okay. So you have to install Minikube in your machine. I already installed it before, so you can see he is Minikube will put the image. There's the VM. Let's say it's like a VM. Minikube is like running a VM and your Docker. So calling the image should be started in a few seconds. once we start Minikube, it will be ready to use, which is amazing for sure. But this is only for development purpose. But you cannot deploy a huge application in Minikube for sure, because Minikube has only one node. So we'll create a Kubernetes cluster only with one node. So now this image is using Kubernetes 1.18.3. We have now 1.20 and they're working on 1.21. So it should be really okay. It's actually like up to date. Now he's like Minikube is verifying that everything is running, and voila. So if I try to say sorry, it's so Docker PS now. Okay, you will sorry. So now we have a Minikube. It's ready to use. Okay, we need to install our application or the MongoDB first. So let's go to the cube here, the cube folder, which has our two YAML files. Okay, so Kubernetes has a very an amazing CLI called kubectl. Okay, so kubectl has many. You can use kubectl to deploy your application, to delete your application, to get information about your application, to get logs, to list your pods, anything. It's just kubectl, and the magic will happen. So to deploy the application, we will use kubectl apply and give it the name. Okay. So as you can see here, if we kubectl get bot, you'll find here. Oh, let me delete this because it was already kubectl delete bot. Okay. So you will find here that MongoDB is up and running and everything is okay. We can actually delete everything and start from scratch to. Okay. So now everything is deleted. Let me try again. Not the time to, yes. So now if we go here, we can also delete the application. Okay. Let's try that. So here, if we say kubectl, we get pods. There is no resources. We deleted everything. Okay. So let's try again to install the Mongo. And you can see here it's running. It just took 5 seconds to have your Mongo up and running. You can imagine that. So now I will deploy the remote application. And as you can see, it's up and running, but it's still containing. Oh, there's something wrong. Let's see what's happening. So kubectl describe, it's another capability, describe a bug that called this name. And you will find everything related to this bug here. The namespace, the name, the nodes running on, the starting time, the labels we have been added, the IP for this, the container ID, the image name, everything. So described as like a magic, okay? So we can see even the events, okay? So now, they assigned they assigned a container for me. Yeah, pulling the image, successfully pulled the image, created, started. Okay, so it should be okay now. If we do that, yeah, it's running. So everything is running. Any problem, you should have it here in the events. If no, you can, if it's not, like there in the describe, you can use logs. Okay, so kubectl retrieve the logs for this. Okay. I think then has been changed.
Pod isn't
Yes.
needed. Yeah, you can. Yeah.
Yeah. So this is the logs for this pod. Okay. As you can see, it's like it started successfully and everything is okay. So let me clear that and say kubectl get all. So you will find everything we have created is here. The two pods, one for Mongo, one for mini nodes, the service as well, the mini node service. And as you can see, because it's a load balancer, so the external IP is coming, we are waiting for it to be able to access it. And Mongo service as well. And it's a cluster ID. Also, we didn't specify that this is, as we mentioned, this is the normal and this is the default. And here is the deployment, because the deployment is, like it contains this, yes, but this is easy to delete the service and pod and everything related to many nodes, for example. Just kubectl delete the deployment and it will delete everything. The replica set, it's very important thing, but we will not discuss it today because it's another concept for sure. But it's very important and it will be created automatically with the deployment. Okay, so let me try to check again if the service is ready to use. Not yet, because the mini service, the mini node service, load balancer external IP is not generated yet. So we're waiting for that to be. So while we are waiting, there is a very cool tool called Octant. Octant is actually to help you see the dashboard, the Kubernetes dashboard, in a very cool way. It's an open source project from VMware Tanzu, and you can install it with the command line. If you have Mac, it's pro install Octant, and you can see it here. It will open this for you, and you will have your whole cluster between. Okay, you will have your own cluster, and your like in front of your eyes. Very easy, very simple. So the deployment is here, the pods, the services, and everything. The persistence volume you have created, and anything we created, you will find it here. So the services, let's say, see the service. Okay, it's not created yet. Yeah, it's created. So now what happened here? You have to tell Minikube that I need to access the service, right? So it's running locally inside the Kubernetes cluster, and I wanted it to be, like running inside, outside the Kubernetes cluster and my local machine. So there's feature called port forward. So it's just kubectl port forward and give the ID that you wanted to forward it to your local host. Using this, open, and we have the application up and running in Minikube, as you can see. So this is Minikube, and we are running our application. And it's working, hopefully. Yes, it's working. Okay, so now we have it working. Okay, you need to see more. How about going to the pod here, the Mongo pod? Sorry, the mini node pod, and see the logs. You will see everything's here related to this. It's the logs. If you wanted to run anything inside your pod, you can use this terminal. It's really cool. Octant is one of my favorite tools. The link will be in the reference, actually. I put the link in the reference. Okay, so this is great. Now we have everything running in Minikube. We make sure that our application is running successfully locally. I need to run it in the cloud. So let's do it very quickly. Uh, First thing, we need to log into Azure. So easy login. It should open. It should open here, something like that. Okay, and you should successfully be able to log in here. Okay, and what I will do now, after clear for sure, is to tell. I already created an AKS cluster, just like to save time. If we go here, I've already created this demo cluster. It's like it doesn't have anything. It's just an AKS cluster. It's a Kubernetes. AKS is Azure Kubernetes service. So it's a managed Kubernetes on Azure. Okay. So okay, I have it already up and running. So what I'm doing now, it's saying, hey, Azure, get me the AKS cluster. Okay, get the credential for this AKS cluster, that new Feli demo, and in the resource group called Feli demo, and make it available in my machine. Okay, get the context for this cluster. Okay, so it will add this cluster to a file called config, .cube config, which contain all context for all Kubernetes cluster that you have been accessed in this machine before. Okay, so perfect. What else? If you wanted to make sure that you are in the correct Kubernetes cluster, try to get all. Oh, we don't have anything. Why? Because this is the AKS cluster, not the Minikube anymore. Okay, so we don't have any pods running. We don't have anything yet. Okay, so let's do it again. Very easy. It's as simple as that. kubectl, apply, -f, the Mongo, YAML file first. Let's see. Okay, it's pending. Should be created in a few seconds. Okay, and while it's created, or maybe you can wait or not. So let's see what's make it pending. Let's try to describe our pod, but as in so yeah, so failed scheduling. Why? Because there is a persistent volume we wanted to create. It should be created now. Yes, it should be created now. So the pod was waiting for the persistent volume to be created. Okay, so if we describe it again, yes, it should be started now. So the pod is started successfully. The second one, kubectl apply, let's add a new node application. All right, so we have an application here. So if we do that kubectl get service, you will see here that the external ID is already been created. Okay, so the application is ready to use. Let's go to Octant again and see our faster. You will see now the context changed to fail demo, okay? And it has just been created, the MongoDB and the menu or the menu node. We can go to the service here. And so, hey, please, we wanted to access this, and you'll be able to access. And it is working. Okay. Now, if you wanted to test that maybe the persistent is still working, we can go again here, maybe, for example, and add this slide, for example, here, and publish, okay? And go back, go to your MongoBot and check, okay? So you'll see here, create a new one, just for 6 seconds ago, okay? And delete the other one. Now, oh, it's still here because we have a persistent storage or persistent volume. Okay, so regardless if the pod is still up and running or not, we have our data because we introduced the persistence volume. Okay, so now, as you can see, I don't care about the pods. I don't care if I have 10 pods or one pod. If like 9 of them are already failing, I don't care. Kubernetes will manage this for me. Once this is deleted, Kubernetes already created another one for me immediately without me asking anything, and we keep everything in this state all the time. Yeah, I think that's it for the demo. Any question before going back to the presentation?
So just one question, Hiba. The question is, does a pod usually only contain one application type, or could it contain the Java app and a Mongo app?
I think I mentioned this before. It can contain many containers, but it's not best practice for sure. As you can see here, we can kill the pod. The pod can be crashed. You don't want to do this for for multiple applications at the same time. It's not a best practice for sure. And also, if you wanted to scale up or down your application, it's very convenient to have just one container to scale it up or down. But if you have multiple containers, it will not scale. Like every time you create another pod for your application, you will create another pod for MongoDB. And I don't need that. I don't need all these containers, all these pods for Mongo. I need just one pod to run my database. But for sure, if I have like a lot of users using mini node, I wanted to create as many pods as I want. So try to separate them. This is best practice. This is the right thing to do. Okay. Should we continue?
Yes, go ahead. There's no more questions right now.
All right, perfect. So after the demo, we will talk a little bit more about the concern that will come when you are trying to containerize a Java application. The most important, or the most two concerns is memory and CPU. Most applications in production today are still using Java 8 or older, and this might be a big problem. Why? Because Java before Java 8, and actually before update number 131, doesn't play nice with Docker at all. The problem is that the amount of memory and CPU available to the JVM is in the total amount of memory and CPU of your machine. It is what Docker is allowing you to use. To fix this problem with Java 8 plus, it's just to to define a maximum memory limit. Okay, in an older version, you have to set this limit inside your container. And it wasn't convenient, and like you have to take care of this, otherwise your application might crash or might use all the memory in your machine, and it should be like a built-in support. Why? Because like it depends on this, the CPU limit. It depends on the C group, and C group should be like built-in support. You shouldn't do it like manually. The second thing about the CPU, that the JVM will look at the hardware and detect the amount of CPUs there. Actually, it will optimize your runtime to use those CPUs. But again, Docker might not allow you to do this. So before Java 8, no, there is no way to fix this problem. So starting Java 10, they address this problem actually, and it's fixed now. So you can control the CPU limit. But by default, the JVM will guess the available CPU and memory resources, and by default will use quarter of the available memory, 1/4. And sometimes you might not need this. It's like, why I'm running only 2 applications or something like that. Why I need like 1/4 from this application, from the memory of my node to be addressed to one application. I don't want this. So thanks to a lot of work have been done from OpenJDK supporters, many issues have been addressed. But again, in early Java, anything before 8, it doesn't work well with containers. So you have to take care. You have to be very careful when you containerize your old Java application, and make sure to set the limit and Java heap and all these things. If you have any chance to upgrade, this is amazing. This is what all we need. But if not, so you have to set the limit. And there's another option after for Java 8 and 9. It's like a C group memory limit for heap. You have to set it as well. Now we will talk about the best practices. When creating a Docker image, if you remember, I pulled an image for the GRE. This called a base image. This is what I need to build my Docker image. So I need another image to build my image. The base image you choose is essential because it allows you to utilize everything available in this image. However, this is a tricky part, because when a base image has a vulnerability, you will inherit this by default. So yeah, and this is why building your new Docker Java image should use a minimal base image as you can. So don't use a fancy image that has everything. No, don't do that. Use like the minimal base image you can use. And actually, this is a good, has a good benefits more than like from security perspective. If you will reduce the size for your image if you use a minimal base image, and therefore the startup will be faster, which startup time will be faster, which this is what you want. How can you make sure that everything is okay? And from security wise, there is a lot of container security scanner tools out there now. They can run consistently in your pipeline, or against your Docker repository, or your ACR, Azure Container Registry, or anything like that, to make sure that there is no issue, there is no attack happen, or anything like that. from these tools, there is Claire, there is Aqua Security, there is Docker Scan, there's many of them. You can choose for sure. But please take care of this base image, because as you can see in this photo here, OpenJDK discovered a lot of vulnerability with Debian or CentOS OS, CentOS as well. So it's maybe you cannot expect that. Maybe you cannot expect that, like if I run OpenJDK with, like Ubuntu, I will have this vulnerability. So you have to take care. The second concern, or the second best practice you have to take care of, is using GRE, not the JDK. And actually, it's relatively related to the first one. When creating a Docker image, we should only assign the necessary resources to function correctly. This means that we should start by using an appropriate Java runtime environment for your production image, not the complete Java development kit that most probably I will not use it. In addition, your production image should not include any build system like Maven or Gradle. And in the Docker file we have created, we can add another steps to build the Maven, to build and to run Maven clean install inside our container, but this is not recommended. So enough is enough. The least thing you can do is better. So if you can just give the Docker file, the jar file or war file, that should be enough. You shouldn't do more than that. The next thing is, don't run your Docker container as a root. Do you remember when we started to build our Docker file, we defined another user and we never used it? This is totally fine, because this is, from security perspective, it's better. It's not a root image right now. No one can just take it and run a script inside this container. So anyone will use this container will have this vulnerability for sure. So just create a user for this image for specific use, and don't use the root user. And make sure, because it's by default is a root user. So if you didn't add in user, it will be by default the root. And I think we have talked a lot about the CPU. And actually, when you specify a pod, you can optionally specify how much of each resource a container needs. The most common resources to specify are CPU and memory. Each of them has an initial request and limit. When you specify the resource request for containers in a pod, the scheduler, do you remember the scheduler inside our control plane, uses this information to decide which node to place this pod on. And when you specify the resource limit, okay, for a specific container, the node enforce this limit to be to not for the container to not use more than this limit. So this information is very important, especially with Java application, because sometimes it might take a lot of memory or CPUs. So you have to be aware. You have to set your CPUs and memory requests and most probably limits. The tricky part here is there is no equation to know what what is the best number to use for requests or for limits. This will you have to add, at least for CPU request or memory request, an initial value, and try to benchmark your application and track your application, see the logs, see everything like that, to make sure that your application is healthy and it's running in a very good, stable way. Doesn't have any a bad startup time, or doesn't have a lot of CPUs. So it will be like trial and error, but at least put an initial value until you know the perfect value for your CPU and for memory from your application. Another another really best practice. It's to implement a readiness and liveness prop for your application. For example, in Spring Boot here, we can use the actuator to just use its out of the box to make sure that the readiness and liveness is already implemented. What is just in case the readiness is perform readiness prop periodically until it succeeds, means that the pod is ready. But the start performing liveness prop periodically until it fails, and then kill the pod. So the readiness will tell you when the pod is ready. The liveness will tell you when we need to kill this pod and create another one. So it's very important. It's really recommended to implement them. And if we have time, maybe next time we can update our deployment file to add this liveness and readiness. Last thing I can see, I can tell if you can use one of the cloud native framework and Java framework, please go and use one of them, like Quarkus, like Micronaut. It has a lot of good points, and they already targeted a lot of these issues that we just mentioned, like the startup time and the memory and the CPU limits. But if not, for sure, there's a lot of hacks. But just make sure to to track the memory and the CPU until you find it's in a good state. So Reza, for this point, I think I will. The only thing still missing is Quarks. I will talk about Quarks, and I will talk about comparison between Quarks and Spring Boot. So till here, I think it's a good point for people if they wanted to stop.
Okay, so folks, please feel free to drop off. We're going to continue on a little bit longer. But as I said, we are recording the session, so you could revisit this URL and the video will be there for you. Obviously, you're also welcome to stick around and finish the session with us. It's up to you.
Okay. So one of the most promising Java Cloud native framework now is Quarkus. Quarkus is actually a full stack Kubernetes native Java tailored from Graal VM, and there's I put the link here. There's a lot of information about Graal VM. It's a JVM, very fast, has no startup time, and it has a lot of really everything you may think about that you wish that Java has someday. It's in Graal VM. It's really amazing. It is made for Java. Quarkus. It is made for Java virtual machines and native compilation to optimize Java specifically for containers, and enables to become an effective platform for serverless and for cloud, for Kubernetes for sure. So Quarkus designed to work with popular Java standard and the frameworks, and actually there is a lot of libraries like Eclipse Micro Profile, Apache Kafka, REST Easy, Hibernate, Spring, Camel, and many more. You can use Quarkus with any one of them. Also, it's very cool feature built in Quarkus is one of actually I feel like it's a major product. It's a major feature. Is as a Java developer, what's your life? Write a code, compile, deploy, refresh the browser, repeat. Write the code and so on. So they shipped a live dev mode automatically with Quarkus. So you just write the code, refresh the browser, and repeat. You don't have to compile. You don't have to deploy. Quarkus will do this for you. So imagine your life without being able to, like it's a lot of time just wasting deploying and like compiling your Java application. And also, Quarkus is based on the CDI, the context and the dependency injection framework. And the last thing is it has only one configuration file. It has a unified configuration file for everything. It's not like you have a configuration file for your database and another configuration file for your environment variable and another configuration file for your application. No, only one unified configuration file. You have everything in it. And this is from Quark's website actually, and there is a lot of people do the same benchmark. So as you can see here, the memory in megabyte, it's like an amazing and REST and the REST or REST plus CRUD. It's very fast. The first response, it's like nothing like any other any traditional Java framework. So it's really amazing. You have to go and try it as well. So this is another. We would have two aspects here about the comparison. The first one, from perspective is performance, and as we mentioned, this is actually a comparison between Quarkus and Spring Boot, and this is Quarkus running directly on Graal VM, but this is Quarkus running on another JVM, and this is Spring Boot. So as you can see, the startup is nothing. You will never notice your application is already started. And if you can compare this to the Quarkus, like Spring Boot to the Quarkus, it's really hard to compare. And also for the memory footprint and for the first response and stuff like that, there is nothing to compare but per megabyte. And the second criteria is the features. There's many features to compare, but I just picked some of them. So this is what we need to see right now because we are talking about Kubernetes. So the Kubernetes resource generation, Quarkus already ship with everything related to Kubernetes already defined. So you can just write your code to define a resource for Kubernetes, very easy. And for sure it supports Graal VM. It's and the dependency injection, it's CDI, and actually the Spring DI as well, the dependency injection as well. They have an extension for Spring dependency injection in case you have a library like already written in Spring Boot. You shouldn't go and rewrite it in any way. So they have this extension as well. The reactive web stack, they're using Vertex compared to reactive for Spring, and for sure they have the project starter like Spring. So just if you go here, you will find it's similar to Spring. So you can define whatever you want to use, and you will generate your application. You can push it to GitHub. You can download it as a zip file or share it with anyone else. And you can, for sure, it's we can use Maven or Gradle. So here is the Maven, and Gradle is already available. So it's really cool. It saves a lot of time and a lot of effort for Java developer. I think it really worth to try if you have some time to play around. Finally, the resources. So I picked some resources if you wanted to learn more about Kubernetes. There's an amazing series from Brandon Burns about Kubernetes basics. Brandon Burns is one of the Kubernetes creators, and he's working now for Microsoft. But it's amazing. It's very easy. You can just follow and you'll understand everything. And here is the article that talk about the Java 10 and how this improved the containers problem, the Docker containers problem. And here is Octant, my favorite tool, and Scaffold. It's really, you have to go and check this as well. And why we created a Docker networking to hook the two containers together. And actually, these like little free resources for you, if you wanted to grab some of them, it's really cool books. It's small, not that big. You can just read them. The code and the demo will be here, and the slide as well. Yep. Open for question.
Okay, so Hiba, last question here. I think, do you think it is worth it for an existing Spring Boot application to be ported to Quarkus or Micronaut? Now, another thing that I did want to add here, it's not just about Micronaut and Quarkus either. So, for example, in March, we will have a talk on Helidon, which is yet another cloud-native framework. So there's a number of these, Helidon, Quarkus, and Micronaut are the principal ones, but there are a lot more that actually implement the microprofile specification. So if you go to, for example, microprofile.io, you will see some examples of what these more cloud native, let's say, frameworks look like. So, but I'll let Hiba answer the question. So the question is it worth it to port an existing Spring Boot application to Quarkus or Micronaut?
I'd say yes. If you have the capability and the time to do some refactoring, you can at least hook your Spring Boot application to Quarks or any other cloud native. The difference in startup time and request time, you can do this benchmark. You can search for many benchmarks already have been done about this, and lots of people already moving from non-cloud native framework to a cloud native frameworks like Quarks or Micronaut for sure. It's really recommended, but if you have the time and the capability to do this, I know it's a bit hard.
Okay, so one thing I will add here is that VMware is making some effort in refactoring Spring Boot, in particular to make use of Graal. Now, obviously, we will all have to see how successful they are in doing that and what actually is the performance benefits. But it is worth noting that there is some work being done with Spring Boot to make it a little bit more cloud native also. So that's, I think, we shouldn't forget that. Yeah. So I think if we have any last minute questions for Hiba, please ask them now. It's been a long session. She's been a trooper. Basically going on for almost 2 hours, giving you everything that she's got. I think it really was a really good session. So if you have any more questions, please post them now. Otherwise, I think we'll thank Hiba and thank everyone for attending this session also. Any other questions? As a developer who has only 1 year experience with Spring Boot, is it a good idea to jump directly to Quarkus? You want to answer that?
Yeah, I think yes. There's no harm. It's just like two different frameworks, and actually Quarkus is really straightforward and has a lot of documentation, good documentation. You can for sure try it. Actually, I recommend to try it so you can compare yourself, because you don't have any preference, internal preference, because you have your application written in specific language. So yes, please go ahead and try it.
Okay. Any other questions from anyone?
And please reach out to me anytime in Twitter or in LinkedIn. You can just drop your question and I will try to answer as soon as possible.
Okay, I think let's wrap this up. Thank you everyone for attending. The video will be available in the same URL, and hopefully we get to see you in the next few months. We have a exciting few sessions coming up. As we said, if you want to look at another cloud native framework that implements some microprofile and some of the Jakarta APIs. We'll be doing Helidon in March, and hopefully a few more. What are the Max services deployed in Java as seen by you? What were the Max services deployed in Java as seen by you? Not really sure what that means, to be honest. Yeah, I'm gonna assume what are the most popular frameworks. I think Spring Boot is definitely popular, but we are seeing here and there, beginning to see some deployments of these other frameworks like Micronaut and Quarkus and Helidon and so on. Okay, we have one more question.
Yeah, he meant like microservices. Yes.
Microservices. Yeah, I'm not really sure what, to be honest, how to answer that. Yeah. All right. Thank you very much, everyone. Have a good evening, and hopefully we'll see you next month. Thank you, Heba.
Thank you. Bye.
Bye.